Now we look at problem 4, and over here we have a graph of a function f on the closed interval from 0 to 7. Okay, so from this graph we can see that when x equals to 0, then f0 equals to 5. That is the left endpoint. And when x equals to 7, f7 is equal to -2. That is the right endpoint. Okay, so for the first part, we want to find the average rate of change of the function f on the interval from 0 to 7. Okay, so here we need to recall the formula for the average rate of change, which is, I will abbreviate average rate of change as ARV equal to FB minus FA divided by B minus A. So here we can view B equal to 7 and A equal to 0. So plug in the numbers, we will have F7 minus F0 over B minus A, that is 7 minus 0. From the graph, we can see that the function value of f at 7 is equal to -2. So f7 is -2 minus the function value at 0, that is 5. And then divided by 7 minus 0, that is 7. If we do the algebra, we can see the average rate of change of the function f on the interval from 0 to 7 is equal to -1. Okay, this is the first part. And then for the second part, we want to find the slope of the secant line that passes through the points 0, 5 and 7, -2. Basically, the slope of the secant line has the same meaning as the average rate of change of the function from 0 to 7. So because we already find the average rate of change of f from 0 to 7 is equal to -1, then the slope of the secant line that passes through the points 0, 5 and 7, -2 is also equal to -1, which is also equal to the average rate of change. Okay, so this secant line is actually the straight line connecting the two endpoints. So it is actually this straight line in the purple. Okay? Alright, for the third part, according to a theorem we learned in this course, we can conclude that there exists a point P on the curve of the function f such that the slope of the tangent line at P is equal to the slope of the secant line you obtained previously. So we want to determine the name of this theorem. So basically, we already got the secant line on the graph, which is in purple. And then, according to a theorem, we know that there exists a point P on the curve of f such that the tangent line of the slope of the tangent line at P is equal to the slope of the secant line passing through the points 0, 5 and 7, -2. So basically, this is the what the mean value theorem tells us. So basically, we can conclude the third part. The name of this theorem is the mean value theorem. So if we want to actually plot such a point P, we can see this P is one candidate, but we can also see that on this part there's another candidate for P. It has the same slope as the secant line. So those two are the possible points of P. Okay, this is this problem.